Hello everyone. I am T. Shivapriya, Assistant Professor, Department of Physics from St.Josephs College of Arts and Science for Women, Hosur. In this video, we are going to discuss about quantum numbers associated with the vector atom model. We know that an atom is the smallest particle of a chemical element possessing the chemical properties of the element. The first model of an atom was given by J.J. Thomson. Thomson conceived his atomic model as a sphere of size 10 power minus 10 meter and of positively charged matter in which electrons were embedded. But this model could not explain all the features of optical spectra of hydrogen and other elements. In order that, in 1911, Rutherford performed a number of experiments on the scattering of alpha particles by a very thin gold foil. There are many models to explain the atom, like Rutherford nuclear atom model, Bohr atom model, then vector atom model. In this topic, we are going to discuss about quantum numbers associated with the vector atom model. There are 7 quantum numbers. They are principal quantum number and it is denoted as small n, orbital quantum number and it is denoted as L, spin quantum number it is denoted as S, total angular moment quantum number J, magnetic orbital quantum number Mi, magnetic spin quantum number Ms, and finally magnetic total angular momentum quantum number Mj. Principal quantum number and it is denoted as n. This quantum number belongs to the principal orbit to which the electron occupied. It takes the only integral values excluding 0 so that n is equal to 1, 2, 3, 4, etc. The angular momentum of the electron in this orbit is nh cross by 2 pi. Orbital quantum number. This quantum number defines orbital occupied by the electron. It takes all the integral values from 0 to n minus 1. This may take the integral values 0, 1, 2, 3, 4, etc. up to n minus 1. Thus, if n is equal to 2, L is equal to 0, 1, where L equal to 0 is called the S electron. If L equal to 1 is P electron, L equal to 2 for D electron, then L equal to 3 for F electron and so on. The orbital quantum PL of the electron is given by PL is equal to LH cross. Spin quantum numbers. This has only one values equal to 1 by 2. According to the wave mechanics, Ps is equal to root of S into S plus 1 into H cross. Suppose if the spin is clockwise means it takes the plus integral value. If the spin is anticlockwise means it taken as negative value. The magnitude is always 1 by 2 since the electron can spin in clockwise or anticlockwise direction. S can have two values is plus 1 by 2 or minus 1 by 2. The plus 1 by 2 values indicates clockwise spin and other indicates anticlockwise spin. Total angular momentum quantum number. It represents the total angular momentum of the electron, which is the sum of the orbital angular momentum and spin angular momentum. The spin angular momentum S is equal to plus or minus half The vector sum of the electrons, orbital and spin angular momentum, if these two electrons act in the same direction J, is L plus S, and if they act in the opposite direction it is L minus S. The total angular momentum is Pj is equal to Jh by 2 pi. Then move on to magnetic orbital quantum number, and it is denoted as ML. The projection of the orbit quantum number L on the magnetic field direction is called the magnetic orbital quantum number. The possible values are L, L minus 1, L minus 2, etc. up to 0, minus 1, minus 2, etc. up to L. There are two L plus 1 possible values of ML. L cannot be inclined to be at any other angle. This is known as the spatial quantization. Magnetic spin quantum number. This is the projection of the spin vector S along the direction of the magnetic field. The spin angular momentum can assume only two possible positions with respect to the magnetic field. It may be parallel or anti-parallel. Ms can have only two values, plus 1 by 2 or minus 1 by 2. Magnetic spin quantum number. This is the projection of the spin vector S along the direction of the magnetic field. The spin angular momentum S can assume only two possible positions with respect to the magnetic field. It may be parallel to it or anti-parallel. Ms can have only two values, that is plus 1 by 2 or minus 1 by 2. Finally, the magnetic total angular momentum quantum number Mj. It is a projection of total angular momentum vector J on the field direction. Since J can have off integral values, J is equal to L plus or minus S. Mj can have half integral values. The possible values are minus J2 plus J, excluding 0, or total is 2J plus 1, values for excluding 0. This is the diagram for the magnetic spin quantum number, and this is the projection of the spin quantum number in the field direction. Ms can have value 1 by 2 and minus 1 by 2. This diagram shows that the magnetic spin quantum number Ms can have values plus 1 by 2 and minus 1 by 2. This diagram shows that the magnetic total angular momentum quantum number. It indicates the projection of total angular momentum. The state of an electron of an atom is completely specified by the four quantum numbers, mainly N, L, Ml and Ms. Thank you for watching.